Welcome back. This is Ramas and it's me, Priska Joseph. Dear students, in the previous class, we discussed some basic concepts of polynomials. So in this class, we are discussing some important concept. Okay? Before starting our class, if you're watching my channel, please subscribe it and don't forget to hit the bell icon for the notifications. Your comments are valuable for me, so please comment below. Don't wasting our time. Next topic is zeros of a polynomial. What do you mean by zeros of a polynomial? The value of the variable in which the polynomial becomes zero is said to be zero of a polynomial. If we substitute a value for the variable and the polynomial becomes zero, okay, then the value of that variable is said to be zero of the polynomial. Okay, let me show you how it works. Let P of x is equal to 2x minus 2. Okay, this is a polynomial and assume x is equal to 1. Okay, so let's substitute x is equal to 1. Then what happens? P of x is equal to 2 into 1 minus 2. Okay, 2 into 1 which is 2. Then minus 2 is there, 2 minus 2 which is equal to 0. Now the P of x become 0. How? If we substitute x as 1, then we get the value of the polynomial as 0. Then we can say that this x is equal to 1 is said to be the 0 of the polynomial. Okay. Is it clear now? If we substitute x as 1 in this polynomial, the value becomes 0. Then we can say this x is equal to 1 is the 0 of the polynomial. Okay, clear? So this is the basic concept of 0 of a polynomial. And next topic is, what is the geometrical meaning of the 0 of the polynomial? Let us discuss. So now let us discuss what is geometrical meaning of zeros of a polynomial. Geometrical meaning means using graph. Okay, by plotting graph or by using graph we have to find out zeros of a polynomial. So there is a question that is, let P of x is equal to 2x plus 3. Okay. So we have to find out zeros of polynomial by using graphical method. Okay, we have to roughly find out the value of 0 of this polynomial. So what to do is, we have to equate this polynomial with a 0. Okay, then 2x plus 3 is equal to 0. Then 2x is equal to minus 3. On transpose, this plus 3 changed into minus 3. Okay. Again on transpose this 2 to this side, then it become minus 3 upon 2 which is equal to minus 1.5. So this minus 1.5 is said to be 0 of the polynomial. Okay, if we substitute any value to x, then the polynomial becomes 0. Then it is said to be the 0 of the polynomial. If we substitute minus 1.5 into this equation, it becomes 0. Then we can say that this minus 1.5 is the 0 of the polynomial. Okay, clear? Now, we have to plot a graph. Before plotting into the graph, we need to find out the ordinates of the line. Okay, so there is x and y axes, x, y. Okay, now what to do is, let us find out x and y ordinates. So 2x plus 3 is equal to y. We have to substitute 2x plus 3 is equal to y. Then if x is equal to, we have to use any points. Okay, here I am selecting x as 1. In the first case, we have to take x is equal to 1. Then what happened actually? 2 into 1 plus 3 which is equal to y. What is 2 into 1? Which is 2 plus 3 which is equal to y. That is 5 is equal to y. Okay, that is y is equal to 5. Okay, so if we consider x as 1, then y will be 5. Clear? Okay, now let us assume another value, that is x is equal to minus 1. What happened? Substitute this minus 1 in this equation, then 2 into minus 1 plus 3 is equal to y. Okay, so 2 into minus 1 is minus 2. Okay, then minus 2 plus 3, which is equal to y, which is equal to, what is minus 2 plus 3? Minus 2 plus 3, that is 3 minus 2, which is equal to 1. Okay, so we get y as 1. Okay, so if we take x as minus 1, then y will be positive 1. Okay, and now we get two ordinates as 1 comma 5 and minus 1 comma positive 1. Okay, so let's draw a rough sketch. Dear students, you have to use graph paper. Okay, otherwise you can't get the answer correctly. Using here a rough sketch. Okay, so the points are, this is 0, this is x-axis and this is y-axis. This is y dash and this is x dash. 0 is the, now 1, 2, 3, 4, 5, 6. Okay, here in minus x-axis, that is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay, here positive side, which is 1, 2, 3, 4, 5, 6. Here it is minus 1, minus 2, minus 3, minus 4, minus 5, finally minus 6. Okay, these are enough. Okay, so now the first point is 1 comma 5. So 1 is here and 5 is here. Okay, so the point will be approximately here. Okay, 1 comma 5. Okay, so the next one is minus 1 comma 1. Okay, so here it is minus 1 and here the point is 1. Okay, and we have to connect these points. Okay, by using a scale we have to join these 2 points. Okay, this is minus 1 comma 1. If we extend this point to the x-axis, it touches a point like this, and the point at which the straight line touches on the x-axis is said to be the 0 of the polynomial. Okay, the line which touches on the x-axis is said to be 0 of the polynomial, and which is the value? It will be approximately, this is not a correct figure, you have to use graph paper. Okay, and this will be minus 1.5, and this is said to be the 0 of the polynomial. Okay, the straight line which touches on the x-axis. Okay, what happening actually is the point should be like minus 1.5 comma 0, and this point, the ordinate of this point should be minus 1.5 comma 0. Okay, if any point which is in x-axis, then the y-axis of that point should be 0. Okay, and similarly, if any point on y-axis, then the x-ordinate of that point should be 0. Okay, is it clear? So now the point is minus 1.50, that is 0 of the polynomial is minus 1.5. Okay, hope it is clear for you. If you have any doubt, please ask me in the comment section. Okay, and now my question is, if another graph. I am plotting here another rough sketch like this, and there is another polynomial, and we get a line like this. Okay, and here the line touches 2 points on the x-axis. Then we can say that there are 2 zeros of polynomial. Okay, in this case the line touches only a single point on the x-axis. Then we can say that there is only 1 zero of polynomial in this case. If another graph, it will be like this. It's a parabolic shape. Then it touches on 2 points on the x-axis. Then we can say that that polynomial has 2 number of zeros. Okay. If it touches one more point like this, see, 1, 2, 3. There are 3 points on the x-axis. Okay. Then we can say that this polynomial has 3 zeros of polynomial. Okay, if it touches on a single point, then we can say that that polynomial has only 1 zero of polynomial. If it touches 2 points on the x-axis, then we can say that it has 2 zeros of polynomial. If it touches 3 points, then we can say that there are 3 zeros of polynomial. Clear? Okay, so that's it. Okay.